When factoring a four-term polynomial, we will use a technique called factor by grouping. Now, it's important to note that not all four-term polynomials can be factored in this way. It does not work in every case, but when it works, it's a very slick method. The first thing that we want to do, that's a good rule of thumb when you're factoring anything, regardless of the technique you're using, is to factor the GCF out from all of the terms, if there is one. If there's a term that's common to all four of the terms in the polynomial, get it out of there before you do anything else. Okay, so then if there isn't any GCF to factor out, or once you've done so, group the four terms into two groups, each containing two terms, and I'll show you what I mean in a minute. And then each one of those two groupings should have a GCF that you can factor out. And then lastly, you'll factor out the binomial that's common to each of them. Okay, if one exists. All right, so let's do an example. So factor the following polynomial by grouping. So the polynomial given is x cubed plus 6x squared plus 4x plus 24. Now, I'm looking at this and I don't see a common factor among all of the terms, right? So if I'm looking for a GCF, the first term doesn't have a number included and the last term doesn't have a variable. So we're kind of stuck in terms of being able to factor anything out from all four terms. But in step 2, it says group the four terms into two groups. So to do that, we're going to group them like so. So I'm going to group the first two terms, x cubed plus 6x squared. Just put parentheses around those two terms. And then also put parentheses around the last two terms, 4x plus 24. Okay, now you want to factor out the GCF from each of those groupings. So from the first two terms, we've got x cubed plus 6x squared. Well, x squared is common to both of them, right? So I'm going to pull out an x squared, and I'm going to be left with x plus 6, right? When I factor out the x squared. X squared times x is x cubed, and x squared times 6 is 6x squared. Okay, now, from the last two terms, I've got 4x plus 24. Well, I know that 4 is a factor of 24, so that's going to be our greatest common factor there. I'm going to pull out the 4. So 4 times the quantity x plus 6. So I now look at this whole new expression that I formed, and I notice that the first term has an x plus 6, as does the second, right? So x plus 6 is common to both of those terms, and I can now factor it out. So if I factor out an x plus 6, x squared will remain in the first term, and 4 will remain in the second term. So I have the quantity x plus 6 times the quantity x squared plus 4. Now, let's check it. If we FOIL this, x plus 6 times the quantity x squared plus 4, if we FOIL this out, so I'm going to have x times x squared, which is x cubed, x times 4, which is 4x, 6 times x squared, which is 6x squared, and 6 times 4, which is 24. Okay, I'm going to clean this up a little bit. I've got x cubed plus 6x squared plus 4x plus 24. So we get the decreasing powers of x as we go. Is that the expression that we started with? It definitely is. Okay. So this is a nice slick method, factoring by grouping. Now let's get a little more practice.